They are literally everywhere, but they're so easy to miss. They're inside you, they're all around you, and they sustain pretty much everything you depend on to live. And no, we're not talking about plants or animals, but a third kingdom of life, one that has been quietly shaping the world for over 1 billion years. So let's dive in and uncover this hidden world, the silent network that secretly runs our planet. When you see a mushroom, what you're really looking at is just the icon on the desktop. It's the pretty little thing that pops up. But the real program, the actual organism, is living completely out of sight. It's this massive, intelligent network that's been shaping our world from the very beginning. I mean, literally eating rock, creating soil, and building the foundation for all life on land. And this leads us to the big question for today. If we start thinking of the Earth as having this ancient biological operating system that's been running for 1 billion years, well, where do we fit in? Are we, humanity, a useful new application? Or are we more like a piece of malware, a virus that's corrupting the entire system? Let's dig in and find out. All right, so to really get our heads around this planetary OS, we have to look at its source code, its fundamental hardware. And that all comes down to one single incredible thing: mycelium. So this is it, mycelium. You can think of it as this ecological connective tissue, a living seam that's stitching the entire world together. So forget the mushroom for a minute. This sprawling, tangled web of tiny little threads called hyphae is the real main character in our story. Get this, a single cubic inch of healthy topsoil can have enough of these threads to stretch for over 8 miles. It's absolutely mind-boggling. And how big can one of these networks get? Well, the largest known organism on planet Earth isn't a blue whale, it's not a giant sequoia tree, it's a honey fungus in Oregon. A single organism. It covers nearly 10 square kilometers, weighs hundreds of tons, and might be as old as 8,000 years. And the crazy part? There are probably even bigger ones out there that we just haven't even found yet. The famous mycologist Paul Stamets puts it this way, and it's such a powerful idea. He says mycelium is the neurological network of nature. And just think about that for a second. This isn't just a passive web of threads. It's an information-sharing membrane. It's aware, it reacts to its environment, it's in constant communication, behaving like a vast, decentralized intelligence woven right into the soil. So what's the #1 job of this incredible network? Well, it acts as nature's original internet, connecting pretty much all the life in an entire forest. This is what we call the Wood Wide Web. But honestly, even calling it a web kind of sells it short. Think about it like this. There's a huge difference between having 20 friends you can send a text to and having 20 friends you literally share a circulatory system with. That's the level of intimacy we're talking about. This is a physical, biological infrastructure. This image just illustrates the idea perfectly. If you imagine a forest is a city, then the trees are the buildings, the mycelial networks. They're all the hidden infrastructure, the power lines, the fiber optic cables, the plumbing, all of it, connecting everything and everyone, and allowing the whole system to work together as one. So how does it work? Well, it's basically a trade. It's a symbiotic relationship. Plants are great at making sugar through photosynthesis, so they trade that energy with the fungi. And in return, the fungi are amazing at mining the soil for crucial nutrients, which they give back to the plants. This network physically connects over 90% of all land plants, letting trees share resources, warn each other about pests, and even feed their own young seedlings. And let's be super clear about this. Without this ancient partnership, plants never would have made it out of the water. They never would have colonized land. This is the foundation of almost all life on land. Okay, so beyond communication, this planetary operating system runs another absolutely critical program. It's the ultimate resource management and cleanup crew. And no, that is not an exaggeration. Fungi are the great recyclers of our planet. If you could just press pause on all decomposition right now, the world would quickly become buried, kilometers deep, in dead plants and animals. Fungi are the interface between life and death. They're what disassembles the old to create the soil from which all new life can grow. And they have a very long history as the planet's first responders. I mean, after every single mass extinction event in Earth's history, from the Great Dying 250 million years ago to the asteroid that wiped out the dinosaurs, it was the fungi that inherited a world covered in debris. And every single time, they surged. They got to work, recycling the ruins and rebooting the entire system for the next chapter of life on Earth.
So, if fungi are this ancient, unbelievably powerful operating system, what happens when we, the new species on the block, finally learn how to write our own applications for it?
Well, this is where it gets incredibly exciting. We're starting to develop a whole new toolkit of what you could call mycotechnologies. I mean, think about it. Using fungi's natural appetite to literally digest and clean up oil spills, or using their woven mats to filter deadly toxins out of our water. We can even grow our own building materials and packaging instead of manufacturing them. From pesticides to forestry, we're just barely scratching the surface of what's possible here.
This quote just perfectly captures the shift in thinking we need. Our technology, our supercomputers, they're just loud, clunky echoes of what fungi have been perfecting for 1 billion years. We build power grids. They are the grid. We're desperately looking for the answers to biology. They are the biology. Okay, take myco-architecture, for instance. The process is just brilliant. You take agricultural waste, like corn husks or wood chips, and you put it in a mold. Then you introduce mycelium. The mycelium grows through the waste, acting like a natural, self-assembling glue, and it fuses everything into a solid block that's super strong, lightweight, and even fire-resistant. We're not just talking about replacing styrofoam packaging here. NASA is seriously looking at this exact technology to grow habitats for the first human colonies on Mars.
So, all of this incredible potential brings us right back to our place in this system. As we learn to harness this ancient power, we also have to face the impact we've already had on it.
But here's a really crucial dose of realism. As exciting as all these new apps are, fungi are not a magic bullet. We can't just outsource our massive environmental cleanup to them, because the operating system itself is being damaged, and we're the ones doing the damage.
You see, the very systems we're now hoping might save us are the same ones we've been systematically destroying for decades. Modern industrial agriculture, with its constant tilling, its fungicides, its chemical fertilizers, it has absolutely ravaged these vital underground networks. It's kind of like taking way too many antibiotics that wipe out your gut microbiome and then wondering why your health is falling apart. This quote from Paul Stamets really makes you think, doesn't it? He asks, what if every other species on Earth got a vote on our planetary impact? How would that vote go? He suggests the answer is probably pretty clear. We've been acting like a parasite, exceeding the carrying capacity of our host. And that brings us full circle. We've seen that fungi are the planet's ancient foundational operating system. We've explored the incredible new applications we're just now learning to build with them. But the final question, the one that really matters, is for us to answer. Are we just a disruptive virus messing with 1 billion years of stable code? Or can we finally learn to work with this ancient intelligence and become responsible co-programmers in the ongoing project of life on Earth? The choice, really, is ours.